This is a pre-built version of the application. So we'll have six peers. And this will be the first one, second one, third and fourth, and fifth and sixth one. And each one of the peers will pick up messages from all others. And even though I'm specifying this same peer, it's not gonna pick up its own messages since it does its own checking. So I have that for convenience since I'm entering it for all the peers. And let's go ahead and start mining on each one of the peers. So this one succeeded in mining this block, and the other 5 verified it. Now hashing is taking a string of any length as input and producing a fixed length output, and here we are using SHA-256, the one used by Bitcoin, and it produces a 256 bit hash, and since we are displaying in base 16, so we end up with this 64 characters. So this is the hash for the username, plus the timestamp, plus continuously varying nonce, and the color assignment, this color assignment. And the proof of work is to have this hash be smaller than this max bound. And we are running in verbose mode. So we start by assigning this color to this country, and it doesn't have any neighbors. So we move to the next country and we assign it this color, and this is its neighbors. And then we move to the next country, and it has this neighbor that we already assigned the same color. So we try with a different color and we succeed. So we move to the next country and we assign it this color, and we haven't assigned any color to any of its neighbors, so we succeed. And we move to the next one, same thing, and the next one, and this neighbor has the same color, so we change the color and we succeed. So we move to the next one, and this neighbor has this color, and this neighbor has this other color. Same for this one. So we try, so here we tried red, we try blue, and we don't succeed, so we try yellow, and we succeed, since none of those has a yellow color. And we move to this country, and it doesn't have any neighbors, so we move to the next one, and its neighbor has no colors assigned to it yet, so we move to the next one, etc. Until we found this color assignment solution. For all the country in the Schengen area. And next we move to trying to hash those username plus timestamp plus nouns plus color assignment, and trying to find a hash smaller than the max bound. And this nouns keeps changing, that's why we keep getting different hashes until we reach a satisfactory one, which is smaller than this max bound. So we send the username and the timestamp and the nouns and the color assignment to those other peers, and what they do is they calculate the hash and make sure that it is smaller than the max bound. So the proof of work here is a piece of data which is time consuming and costly to produce, and this means it needs a lot of electricity that is spent on computing resources. So we end up spending a lot of energy on trying to solve a basically useless problem. Essentially, we are checking if a continuously varying number, meaning any one of those hashes, is smaller than another number, this max bound. So the idea of this prototype is to experiment with trying to solve useful problems with part of the energy spent. Specifically here we are doing constraint satisfaction problem, map coloring, in order to find a color assignment solution. So we spend part of the energy in finding this solution. what I did here is to modify the first cryptocurrency project, this one, and added the CSP map coloring to the proof of work, so this one. Functionality, and we're doing a simplistic approach here for now. So we're just using this color assignment solution as part of the block that gets hashed. And the source code here will be available for download. Also, a longer version will be available for watching by all channel members, and it will include step-by-step coding plus test running the coded application.